This is the Unit 3A reteaching review for Mrs. Sather's AQR class. Hopefully you have your 3A recovery review sheet available so that you can follow along with me. The first thing we need to look at is the difference between observational studies and experimental studies. I've drawn this Venn diagram here so you can see what they have in common and what they don't have in common. They're both studies where people are doing something so that they can answer some kind of a question. Both types of studies have participants. Obviously they need some people or animals or plants or something that are going to be in the study. And both types of studies have a variable of interest. The variable of interest is the thing that is measured in the study. So it could be like the height of a plant, or it could be like the weight of a person, and just anything that the study is trying to understand. Observational studies are done by survey, interview, or observation, and they could be a measurement as an observation. So that could be that you're just seeing how tall someone is, or you're trying to see how many phones somebody owns. It's something that you're not really invading the person's privacy, you're not making them do something in particular, like run a marathon or something. You're just kind of asking questions and trying to see what's happening. And experimental studies are a little different because in these studies they always have 2 or more groups and treatments are used so that they can see if something is more effective than something else. And then placebos are often used with control groups in an experimental study. So experimental studies are doing something to or with somebody or something, and observational studies are just kind of watching. There are a couple of study-related definitions. If you need more of these, there is actually a vocabulary page on the Moodle site. You can click on there and you can look at those and see if there's anything on there that maybe is not defined. So if I use a word in here that you're not sure of, you might refer back to that. Some of our study-related definitions, though, in our worksheet are subjects. Those are persons or things included in the study. So those are the same things as the participants from our Venn diagram. A variable of interest is a thing being measured. It's the whole point of the study. And we mentioned that earlier. That's also in the center of our Venn diagram. Treatments. This is from the experimental study side of our diagram. That is what is being done to or by the participant. So this could be an exercise program, or taking a pill, or trying a new pencil, just anything that's being done differently. And then a placebo is an ineffective treatment. A placebo is something that we know is not going to work, but we have to try to keep conditions close to normal so that we can see if the thing that is supposed to be working actually is working. In our studies we have the population. The population is the entire group being studied in the whole world. So that's everywhere, the entire world, not just like, well, could possibly be just one high school if that's your narrow focus of the study. But a lot of times it's a lot broader than just that. The sample is a small group that's actually in the study. So these are the people participating. So you can tell the difference between population and sample. On very rare occasions these are the same, and if that happens then we're doing a study using a census. But most of the time our sample is just a small representation of our population. Right, so there are a couple of ways that we can gather data. Primary data is data that is gathered by the researcher. So this usually takes a lot of time, so it's supposed to be a little clock right there to show time. And money is kind of expensive sometimes to gather your own data. There are a lot of good things to it because you know that it's reliable because you did it yourself. But still, not always the best way to gather information, especially if you're trying to do a study that goes long term. Secondary data. That is data that is gathered by someone else. It's like historical records. Like you could read a book, or you could read a newspaper, you could go online, you could anything that someone has already done, like a census record or legal documents, court records, anything like that would be secondary data because someone else collects it, but you could still use it if you're doing some type of a study. Alright, as you flip the page, there are 3 different examples, and what you need to do right now is pause the video and see if you can decide for each of the samples on the next page. Is the study observational or experimental? What is the variable of interest? What is the population of interest? Who or what is the sample? And then is the data primary or secondary? So take a moment, pause the video, and try to answer the questions. Alright, hopefully you have answered the questions. Here are the answers. So to problem number 1, Jonathan wants to know if the average height of guys at school is higher than the average height of girls. He measures the heights of 25 guys and 25 girls and compares the results. This is an observation. There were no treatments applied. He simply measured the people. The variable of interest was the heights of the guys and the girls. The population, since he was concerned about students at his school, that would actually be the population. The sample in this study were the 25 guys and 25 girls that he measured. This data was primary because Jonathan collected his own data. The second example is that some sources have suggested that chewing a peppermint while taking an exam increases one's performance because peppermint stimulates the brain. On the day of an exam, Mr. Henning flips a coin for each student. If it lands heads, he gives a student a peppermint. If it's tails, a student does not get a peppermint. Then he compares the scores on the test. This is actually experimental because there are 2 groups and 2 different treatments. One group gets a peppermint and one group does not. The variable of interest are the test scores. The peppermints will be affecting the test scores, but ultimately we want to measure to see if the scores are higher or lower. The population would be all students, and the sample are just the students in Mr. Henning's class. This is primary data because Mr. Henning did the experiment himself and collected his own data. The third example. Haley has been following 2 bills that were recently voted on in the U.S. Senate. One is a pharmaceutical regulation bill and the other is a gun regulation bill. She predicts that, in general, senators who tend to vote for pharmaceutical regulation bills also tend to vote for gun regulation bills. She goes online to find the list of senators for each bill and compares the list. This is an observation. There are no groups or treatments being performed. She is simply looking at the records of the votes that the senators had. The variable of interest would be the voting records. The population is all of the senators. The sample are the senators that Haley researched. In this case, she might have been doing a census because she did use all of the senators' data in her study. So, the secondary data. This time she has collected secondary data because she found the voting records online, someone else kept up with this data, and Haley was simply reading it. Alright, the next piece of our review talks about treatment groups and control groups. So we briefly touched on this earlier. Treatment is what happens in an experimental study. So the treatment group is the group that has the treatment being studied. It has the active ingredient. So this is the thing that we think is going to actually cause some kind of an effect on people or plants or animals. The control group is the group with the closest to normal conditions. So they have the inactive ingredient. They keep doing what they normally do. So if you're testing an exercise program, the treatment would be exercise, and the control group would just continue with whatever exercises they had been doing. But they would not try something new. Alright, so I kind of jumped ahead there for a minute. If you take a look at question number 1, this is the peppermint example. I read it just a minute ago, and we wanted to see if we could identify the treatment group and the control group. The treatment group in this study are the students with the peppermints. The control group are the students without the peppermints, because typically students don't walk into class carrying a bunch of peppermints to eat during a test. So pause this for just a second and see if you can answer question number 2. In question 2, a pharmaceutical company developed a medicine to treat back pain. They recruit test subjects and randomly split them into 2 groups. One receives the medicine and the other group receives a pill containing only sugar. They ask patients in each group to rate their pain on a scale of 1 to 10 both before and 1 week after taking the medicine. So in this example, the treatment group are the patients with the medicine, and the control group are the patients who have the sugar pill. The next piece of our review discusses sampling methods. So here are some of the definitions, and I have some little illustrations that go along with them. So the first one is simple random sampling. You choose a sample through randomization, something like, for example, pulling a name out of a hat, like right here, pull a name out of a hat, or you could be just rolling some dice. So if somebody gets like an odd or even number, then they're assigned to certain groups based on that. It's the easiest kind of sampling and probably something that you might have done before, like to choose teams for, say, some kind of a little activity at school. Right. Stratified random sampling. You separate the population into strata, then randomly sample within each strata. So these we have 3 little groups. You have group 1, group 2, and group 3. And then within those groups you pull names out of a hat so that you're not using every member of the group. It's just a few people that are randomly chosen. So strata, or stratified, is talking about the making of the groups. The random sampling part is the pulling a name out of a hat, or rolling a die, or doing some other randomization technique. Right, systematic sampling. That's when you split the population into evenly sized groups, then choose participant number n in each group. So you split the population. So you'll see we have 2 little evenly sized groups over here. We have group 1 and we have group 2. Okay. And then we've chosen person number 6. They have the check mark beside them in each group. So, like you could make a list. You could go to the office and you could get a list of all the students at R.L. Turner and say you wanted to pick every 43rd person on the list. That would be a way to do a systematic sampling of students at Turner. The next couple of examples are cluster sampling and convenience sampling. For a cluster sample, you split the population into evenly sized groups and then randomly select an entire group to participate. So notice here we have 3 little groups. We have group 1 right there, group 2, and then group 3. Group 3 is chosen, and this time, so you see we randomly chose group 3 by picking a number out of a hat, but we're using every member of group 3 this time. So if you think about our high school, we have advisory classes. So if I wanted to get an idea of what iLead students think about advisory, I might choose 2 different iLead advisory classes and then go ask every student in those classes what we could do to make advisory better. Right, convenience sampling. This is probably the easiest one. You select participants based on easy accessibility. So you notice, like right over here, you've got this little researcher person, and they are choosing the 2 people that are closest to them right there. They could have chose the person out here, but no, they were a little bit farther away, so they didn't do that. So this would be like standing at the entrance to the mall and asking 30 people a question in your research. And that would be a way to do a convenient sampling. So at this point, pause the video, take a minute, flip the page, and see if you can figure out which type of sampling is being used in the situations 1 through 4 about the mini chocolate bars. Alright, did you get the right answers? Number 1 should be a systematic sampling. One of the key words in the first problem is that every 200th bag on the conveyor belt is being chosen. So that is systematic. That's where we had a list and we chose a specific number, like of things off the list. So things coming off of a conveyor belt, if you choose every 200th, that is a systematic sample. For visiting the facilities that manufacture chocolate bars, collecting 500 bags at each factory, if you don't use all of them, you only count 200 random bags. That is a stratified random sample. So stratification, they're in groups. Each set of 500 is a group, but then the stratified part comes from pulling only 200 of those out. Alright, the third one is cluster sample. So every day for a week there are 200 bags of chocolate set aside, and at the end of the week you count all the bags that were set aside. So you form groups, one group for every day, and then use every member of that group. That would be the 200 bags. And then the last one is convenience sampling, because you simply go to the nearest grocery store and pick up some bags and start counting chocolate. So that's kind of the lazy way to do things. But you definitely didn't go out of your way there just to stop by and grab what was available. This next piece is about margin of error. Margin of error, simply put, is a specific amount that a measurement may be off by. So, let's say I were trying to calculate the average weight of a high school age female. I might come up with a number, like 120 pounds. I don't know, something like that. But then whenever I do if I were to do my experiment and then go out and try it, that might be my average, but someone else in another part of the country or another part of Dallas might do the same experiment and they might get exactly 120. So there's a certain number that can be calculated. We're not worrying about how it's calculated for this course. That would be in a college statistics class. But there's a certain acceptable margin of error, so that if the experiment is repeated, it could be a little bit more or a little bit less than the experiment that you conduct. Alright, so in these examples, the average fun-sized bag of M&Ms contained 12.2 candies. 12.2, that's 12 plus or minus 2 candies. Explain what the 12 plus or minus 2 means. Well, the plus or minus 2 is telling us that there might be 12 minus 2 candies or 10 candies in the bag. The plus 2, 12 plus 2, would be 14 candies. So there are between 10 and 14 candies. So if I open up a bag, I might get 10, 11, 12, 13, or 14 candies in each bag. So maybe I should put the label on there, 10 to 14 candies per bag. Alright, the next one. Males with epilepsy have an average of 14 plus or minus 9 micrograms per gram of copper in their scalp hair. What does the 14 plus or minus 9 mean? So, if we do 14 minus 9, that means that someone might actually have only 5 micrograms of copper in their hair. If we do 14 plus 9, that means that somebody might actually have 23 micrograms per gram of copper in their scalp hair. So this little μg is micrograms. So that's how much copper is in there per 1 gram of hair. So interesting. But anyway, the 14 plus or minus 9 gives you a range, so that if you were to conduct the experiment somewhere else, you would expect your value to be somewhere between 5 and 23. Our last piece of the review talks about informed consent. Informed consent is the participant knows all the potential risks and benefits to participating in a study. So you have to be sure that before you do something, especially something that involves taking a new medication or doing some kind of exercise program or anything that might be psychologically damaging to a person, before they participate, the participant needs to know what could possibly happen to them. They have to know all the good things that could come out of the study, and they need to know the bad things that the researcher is aware of that could potentially happen when participating in a study. So, because it is important that people understand what is going on, there are some groups that need some special protection because they have limited ability to understand or limited power to stop some things. So children are one of these groups. Children need special protection because they are too young to make informed decisions that may have long-term influence on them. They're too young to understand psychological effects that could happen from participating in a study. They're too young to understand that if they take a particular medication, while it might possibly make them feel better now, they don't think long-term that maybe whenever they turn 35, there might be some health risk that comes up because of the medication they tried. So they need their parent or guardian to completely understand for them and to be careful with them in a research setting. Mentally ill patients, they do not fully understand what may happen, especially if the mental disability is very severe. They may not be able to adequately express that they do not want to participate or that they want to stop participating. So we must be very careful with these people, that we don't disregard that they do have feelings, they are people too, and so we must treat them very carefully. Prisoners. Because they're incarcerated, they may not feel that they can opt out of a study. So they literally have no place to go if they don't want to participate. So some people feel pressured into it because, well, they're right there. They have nothing else to do. They might be offered some amounts of money, and it's very difficult to get money in prison. So if they pay the prisoners, that might give them an incentive to do something they might otherwise not do if they had other means of earning income. So we have to be careful not to exploit prisoners. In the same way, minorities. Research should be beneficial to all groups. Minorities may not undergo unnecessary risks. So this happened a lot whenever you saw researchers that were maybe racist, trying to conduct experiments on ethnic groups they didn't necessarily like, because who cared if they got sick anyway? It's a terrible attitude to have, and we want to make sure that if a minority is included in a group, that all minorities and the majority are all going to get the same kind of benefits. You don't want to risk someone's health or comfort so that other groups can benefit from it if that person or their particular group may not be able to get any kind of benefit from the research. Alright, so lots of vocabulary. The word vocabulary is underlined down here because, just a reminder, if there's anything in this presentation that you need to have defined, there is that vocabulary page. You might go back up and take a look at it. But now that you've completed the notes, you are ready to attempt the Unit 3A test. Good luck.